Alright, so we're going to solve another equation here. This is intermediate equation solving. Specifically, we're talking about U substitution here. Alright, so here's the equation. Sine of theta plus pi over 4 equals 1/2. And specifically, we're looking for theta, let's call this theta, to be between 0 and 2 pi. Alright, I want to stress the importance of being able to check your answer through graphing. I think this is a powerful tool to check. So, if I set my left side of equation in a y equals, and then set the right side of the equation in a y equals, and all I'm specifically looking for then is where these graphs intersect, specifically between 0 and 2 pi. So the red equation is the sine graph with a phase shift of pi over 4. And then I got y equals 1/2. So where do these intersect? Well, specifically between 0 and 2 pi, that would be, that's not between 0 and 2 pi. Negative pi over 12 doesn't work. 7 pi over 12 is a solution. 23 pi over 12 is a solution. So according to the graph, there's going to be two solutions here. 7 pi over 12 and 23 pi over 12. We're going to find those. Using this U substitution. So we're going to let U equal theta plus pi over 4. And that gives us then the sine of U to equal 1/2. And I can solve this pretty easily just through my knowledge of the unit circle. Sine of U equals 1/2. That's going to happen at pi over 6. That's quadrant 1. Sine is also positive in quadrant 2. So we're going to call that 5 pi over 6. And of course, if we wanted all the solutions, it would be pi over 6 plus 2 pi k, and 5 pi over 6 plus 2 pi k, because this thing keeps wrapping around the unit circle. K is going to be some integer. Now, if you don't understand how it's wrapping around the unit circle, go back and look at the video on basic equation solving, because we talk about that equation. Okay, so substituting U back now, we said U is equal to theta plus pi over 4. So this gives me theta plus pi over 4 is equal to pi over 6 plus 2 pi k. On the other hand, substituting U, I get theta plus pi over 4 is equal to 5 pi over 6 plus 2 pi k. And so now I just need to solve this for theta. And then we're going to test some values. So I'm going to subtract a pi over 4 from both sides. Depending on your knowledge of fractions here, we need to find a common denominator, which is going to be 12. So we'll say this is pi over 6 is going to be 2 pi over 12 minus 3 pi over 12 plus 2 pi k. And so theta here gives us negative pi over 12 plus 2 pi k. Well, let's just do the other side too, so we can solve for theta here. So I'm going to subtract a pi over 4 here. Finding a common denominator, again of 12, we're going to say this is 10 pi over 12. That's 5 pi over 6. 10 pi over 12 minus 3 pi over 12 plus 2 pi k. So theta here is going to equal 7 pi over 12. Now, if they wanted all the answers, that would be it. That's every single answer for theta. But specifically, they told us it has to be between 0 and 2 pi. So what we're going to do here is we're going to start testing values of k. So let's let k can be any integer. Let's just start at 0. If k is 0, then negative pi over 12 plus 2 pi times 0, that's just going to give me negative pi over 12. However, negative pi over 12, this is less than 0. So it's not in our range between 0 and 2 pi. So I'm not going to use that as one of my solutions. Let's let k equal 1 and see what happens. So now I get negative pi over 12 plus 2 pi times 1, or plus 2 pi. So this is negative pi over 12 plus 24 pi over 12. And so theta here is going to equal 23 pi over 12, which is less than 2 pi, so I'll take it. All right, we'll use that one. Let's see what happens if I let k equal 2. Again, we're going integers here, right? So if k is equal to 2, then theta is going to equal negative pi over 12 plus 2 pi times 2. That's plus 4 pi. Right? Well, again, common sense here. I can think about this and say, okay, 4 pi plus a negative pi over 12. That's going to be way over 2 pi. So I don't need to count that one either. So here, I got one answer of 23 pi over 12. The other two were outside the range. All right, let's move back up then to our other equation, 7 pi over 12 plus 2k pi. So we're going to let k equal 0. Theta equals 7 pi over 12 plus 2 pi times 0. So that's just going to give me 7 pi over 12, which is in the range of 0 to 2 pi. So I like that one, 7 pi over 12. Put a box around that. Let's see what happens when we let k equal 1. So that's going to be, theta is going to be 7 pi over 12 plus 2 pi times 1. Well, I can see, common sense, when I take 2 pi plus 7 pi over 12, this is going to be greater than 2 pi, which would be outside the range. So I don't even need to test that. I'm not counting that one. So that means then we have two answers. We got 23 pi over 12, we got 7 pi over 12. I don't have to test anything else because no matter what values of k I test, I'm still going to get things that are greater than 2 pi. Or if I tested k equals negative 1, which is possible because k could be an integer, but I'm going to get values that are less than 0. So the only two solutions that are within the range of 0 to 2 pi would be 23 pi over 12 and 7 pi over 12. Which is the values that I got there, 23 pi over 12 and 7 pi over 12. So everything kind of works out nicely.